All right, y'all, welcome back. Today we are going to talk about 5.2 day 2. If you remember last class in day 1, we talked about nth roots and how you simplify with fourth roots and third roots and fifth roots and things like that. Today we're going to talk about how we add, subtract, multiply, and divide whenever we have radicals. Okay, so we're going to start with adding and subtracting. And up here are kind of the rules when we add and subtract. All right, so the first thing is radical expressions can only be combined if they have the same index and radicand. So remember, the index is the little number in front of the radical, and the radicand is the part inside. So those have to be the same for us to add them, okay? Sometimes you're going to have to simplify the radicals before you can combine them, all right? So we're going to do 3 examples here. Now, you see a bunch of examples. We're not going to do them all. We're just going to do 3 of them, all right? And we're actually going to start with B right here, okay? So it says negative square root of 18 minus 2 square root of 2. Now, one of the things that's really going to help you is this power card. Whoops, let me pull it up for you real quick. Is this power card right here, okay? So remember, this is posted on our modules, all right, and you'll see it, and this will help us because we're going to have to find some squares and cubes and things, all right? So notice that these two numbers are not the same. There's an 18 as a radicand, there's a 2 as a radicand, okay? So we need to make them the same or try to make them the same, all right? So this is a square root. So now what I need to do is try to split up 18 into something times something else, something that's a perfect square. So for example, 18 is the same as if I look at my square column right here, 9 times 2 will give me 18, and 9 is a perfect square. So I'm going to change 18 into 9 times 2 minus this one. This is our 2. I can't really change the 2, so I'm just going to keep it exactly the same. All right? So we had to simplify the 18 first. And if we've done this right, we should know the square root of one of these numbers. The square root of 9 happens to be 3. And then the second one still hasn't changed. Now, if you notice, look, the index and the radicands are the same. They both have a 2 underneath. Once they are the same, we just combine the numbers in front. So now we're just going to combine this negative 3 and this negative 2. So negative 3 minus 2 gives us negative 5, and that radicand stays exactly the same, and we're finished. Okay, so get them to have the same radicand and then just combine the numbers in front. All right, so now we're going to do A. Okay, the same thing. So notice they're not the same. One's a 2, one's an 8. So I need to try to simplify. I can't simplify the first one, but I could simplify the 8. Okay, so the 3 stays in front. This one has a 2 in it. So I need to try to find 2 times something that will give me the 8 here because I need it to match, right? I need there to be a 2 for them to be the same. So if you weren't sure and you went back to your power card, right, this is a square root, okay? If we went back to our power card and looked at the squares, find a way to 2 times what will give us 8, and that happens to be 4, okay? So 2 times 4 would give us 8. And then again, if we've done this right, we should know the square root of one of these. So the first one's not going to change. 2 square root of 2 plus, there's still a 3. The square root of 4 is 2. So that means I'm going to pull out a 2. Now, since that 3 is there, I have to multiply those together. Okay? So I have 2 square root of 2 plus 3 times 2 square root of 2, which turns into 2 square root of 2 plus 6 square root of 2. And now again, look, they match. So since these match, I can just combine the 2 and the 6 in front, and I get 8 square root of 2. Okay, so our goal is to get them to match up, all right? And once the radicands match, then we can put everything together, okay? This third example is a little bit different. So this says the cube root of 2,000 plus the square root of 2 minus the cube root of 128. So notice that there's some of these have a cube in front, cube root, and this one doesn't. So this one's a square root. So I'm still going to try to do the same thing, okay? But I'm only going to be able to combine these two because they both have a cube root. All right, so let's try to split up 2,000. But now I am looking for cubes, okay? So if I go back to my power card, now I look at the cube column. Okay, so I look here and I try to figure out how could I multiply to get 2,000? So if I look down, oh, I see 1,000, right? So 1,000, I could change 2,000 into 1,000 times 2. because 1,000 is a cube. Now the second one, I'm not going to change, square root of 2. But 128 is kind of big, so let's see if we can split up 128. So try to think of something that will, a cube that will go into 128, all right? This one already has a 2. So maybe there's a way I can keep I want to keep the 2. I just have to figure out 2 times what is 128. So again, if I go back to my power card and look at the third column, okay, right here, 64. 64 times 2 would give me 128. Okay, so 64 times 2. So now I've split it up, but now I need to simplify. So this is where either your power card or Desmos will be handy. All right, so the cube root of 1,000, the cube root of 1,000 is, here's the cube root, here's 1,000, the answer is 10. The cube root of 1,000 is 10. So that means I'm going to pull out a 10. So 10 cube root of 2, the 2 stays right where it's at. I can't change this one, right? The square root of 2 just stays the same. And then I got to figure out what's the cube root of 64. So you could use Desmos and type it in like we did in the last section, or go back to your power card, okay, the cube root of 64. So again, if I look at the cube root, here's 64. The cube root would be 4, all right to the left of it. So the cube root of 64 is 4. That means I'm going to put a 4 in front, and the 2 stays on the inside. All right, so now you see this one and this one have the same index. They're both cube roots, and they have the same radicand too. So those are the only 2 that I can put together. So I just add the numbers in front like before. 10 plus 4 is 14. The cube root and 2 stay exactly the same. In this one, the square root of 2, there's nothing I can do with it. It stays exactly the same. Okay? So try to simplify it, okay? Use that power card, let it help you out, all right? Okay, so that's adding and subtracting, all right? The next thing we're going to talk about is when we multiply. Okay, so multiply is different. They don't have to match when you multiply. Okay, they do not have to match. You can multiply outside times outside and inside times inside, okay? So outside times outside, inside times inside, and then we can simplify, all right? But you can't multiply like an outside number and an inside number. For example, on this first one, you couldn't multiply 2 into 3 because one is outside, one is inside. All right, so we're just going to do 2 examples. We're going to do B and F, okay, for when we multiply. So we multiply the same way you guys have multiplied since back in your Algebra 1 days. There's a term in front, so we're just going to distribute it, okay? So we distribute whatever is in front. In this case, the 4 is not under a radical, but the 2 is. So since they're not in the same spot, I can't actually multiply them. Like I can't get 8 because 4 times 2 is 8, but one's outside, one's inside. So I just put the 4 in front. So 4 radical 2. Now this second part, this one is under a radical and so is this one. So I can multiply those together. And if I did that, I would get radical 4. So 4 radical 2 plus radical 4, and then we have to try to simplify if we can. So 4 square root of 2, 4 radical 2 won't change, but the square root of 4 is 2, and now we're finished. Okay, so just distribute like you've always done, all right? And then if you can simplify, do that. So that's the first example. The second example with multiply is now there's 2 terms in each, right? There's 2 binomials. But you guys have done this. You guys know how to do this. We have to either, you might have learned FOIL or just distribute. It's the same thing. So if we FOIL it, right, we have to do square root of 3 times square root of 3, which is the square root of 9, because they're both underneath the radical. Now do the next one. Square root of 3 times 2 square root of 2. So that 2 in front just has to stay because this doesn't have a number in front. But square root of 3 times square root of 2 is square root of 6. All right. Now we're going to do the middle. So the middle 2. So square root of 5 times square root of 3. I can multiply those because they're both inside. Square root of 15. And then do the last one. Square root of 5 times 2 square root of 2. The 2 stays in front. And I can multiply the 5 and the 2. So I get 10. And so here we are. And now I have to see if I can simplify. Is there any way I can break these down to make them a little bit more user-friendly, right? A little bit easier, simplify it a little bit. 6, I can't split up 6 into perfect squares. That's only 3 times 2. 15 is only 5 times 3, so that's not going to work. 10 is 5 times 2, so I can't really simplify 5 times 2. But the square root of 9 we could do, right? So the square root of 9 is 3, and then everything else is just going to stay exactly the same. And there is our final answer. Okay, so it's not always going to come out nice and neat. It's not always going to be pretty. Okay, sometimes you're going to be left with an ugly answer like we have right here. All right? Okay, the last thing we're going to talk about is when you divide. Okay, so when we divide with radicals, we have to do something called, sorry, y'all, my camera's messing up. We have to do something called rationalize the denominator. Okay, you are never allowed to keep a radical in the denominator. Okay, so if there is a radical, if there's a square root or a cube root in the bottom, we have to get rid of that. Okay, and to get rid of that, we do something called rationalizing the denominator. All right, and to rationalize, we have to use something called the conjugate. Okay, it's a big fancy word, but all it means is you change the sign in the middle. So for example, if I had square root of 3 minus 2, the conjugate of that would be square root of 3 plus 2. You just change the sign in the middle. So it's kind of like the opposite. Not really the opposite, but the same idea, right? You just change the sign. If it was square root of 5 plus 6, the conjugate would be square root of 5 minus 6. Okay, so you just do the opposite sign. All right, so that's how we're going to rationalize the denominator. Okay, so let's do 2 examples with rationalizing, and then we're all done. So here's the example we are going to do. The example is 2 over radical 3. Now, I cannot use this as an answer because there's a radical in the bottom. All right, so we need to get rid of that. So to get rid of that, we are going to multiply by something. We are going to multiply by, in this case, radical 3 on top and bottom. Because remember, if I do something on the bottom, I have to do it to the top. Okay? Basically, we're just multiplying by 1, right? Because anything divided by itself is 1. So it's just kind of a fancy way of multiplying by 1 and us getting rid of that radical. And the way we're going to get rid of it is now we're going to multiply straight across. So 2 times the square root of 3, right? I cannot multiply those because this one's outside the radical, this one's inside. So it becomes 2 square root of 3. On the bottom, radical 3 times radical 3, I can multiply those, so I get square root of 9. Now you're probably like, well, there's still a radical in the bottom, right? I didn't accomplish anything. Well, now I could simplify that square root of 9 because the square root of 9 is actually 3. And now I have gotten rid of the radical in the bottom. And this is my final answer. Okay, so these 2 things are exactly the same, right? These 2 things are equivalent. Just this one doesn't have a radical in the bottom while that one does. Okay? So when there's one term, it's not too bad. What happens when there are 2 terms in the bottom? Okay, so this is now where that conjugate is going to come into play. So whenever you have a radical in the bottom, we have to multiply to get rid of it. We are going to multiply by the conjugate. So this is 3 minus square root of 5. The conjugate would be 3 plus the square root of 5 on top and bottom. Okay, so again, the conjugate is kind of like the opposite. And now we have to multiply the top and the bottom. So what I like to do is put these in parentheses so I know it's all one thing. Okay, and now we're just going to distribute. So 5 times 3 is 15. 5 times square root of 5 is 5 square root of 5 because I cannot multiply them together. Okay, now we're going to do the bottom. 3 times 3 gives us 9. 3 times the square root of 5 is 3 square root of 5. Now we do the other one. Negative square root of 5 times 3 is minus 3 square root of 5. And then square root of 5, negative square root of 5 times positive square root of 5 is minus square root of 25. Okay, so I just FOILed the bottom or distributed the bottom. And you're still probably like, yeah, but you have all these radicals in the bottom. Well, if we've done it right, some things should start to kind of cancel out for us. If you notice these two in the middle, one's positive 3 square root of 5, one's negative 3 square root of 5. So those are going to go away. 3 minus 3 is 0. The square root of 25, hopefully you can do that in your head. If not, you can use Desmos or any calculator you have. But the square root of 25 is 5. So that just becomes 5. Nothing else changed. I kept everything the same except square root of 25 became 5. And now you notice all the radicals are gone. So my last step is just to do the 9 minus 5. 15 plus 5 square root of 5. The top still hasn't changed. Over 4. And we're finished. Okay, so get rid of that radical in the bottom by using the conjugate. Okay, so basically just the opposite. All right, y'all, these are the same kinds of questions you're going to see on your Math Excel. If you have any questions, please reach out to me. I'll be more than happy to help. Thank you.